Once I get the tests graded, I'll just give them to you for test corrections for you to do on your own time. Today we're moving on to Chapter 7, 7.1, Inverse Variation. I do not. Sorry.
You're going to have to like test corrections at home?
Yeah. So, we have learned, or you may not have learned, that two variables x and y show direct variation when y equals ax for some non-zero constant a. So I want you to write down y equals ax and write direct variation next to it. Y equals ax and then put direct variation next to it. And our constant a is non-zero, so it's just some number that is not zero. Another type of variation that we have is called inverse variation. So I'll have you write something down for that on the next slide. Does everyone have this written down? Y equals ax, direct variation. Inverse variation. Two variables x and y show inverse variation when they are related as follows. Just need to write this down for inverse variation. Y equals a over x, where a does not equal 0. The constant a is the constant of variation, and y is said to vary inversely with x.
And that's for inverse variation?
Yeah, this is inverse variation.
So, write that problem.
Yep, write it down and put inverse variation next to it. So what do we put for direct variation? Y equals ax. What do we put for inverse variation? Y equals a over x. Constant a is the constant of variation, and y is said to vary inversely with x. Everyone got that written down? Okay. So, here's our first example. Tell whether x and y show direct variation, inverse variation, or neither. What was it for direct variation?
Y equals ax.
Y equals ax. What was it for inverse?
Y equals a over x.
Y equals a over x. So it gives me our problems. Letter A is xy equals 5. What were both equations that we just wrote down solved for? Which variable was by itself? Y. So what do you think I need to try to do?
Get the x to the other side.
Yeah, get y by itself, right?
Yeah.
So how would I get the x away from y if they're being multiplied together?
Division.
Division, right? Inverse operations. That hasn't changed since Algebra 1. So to get x away from y, I'm going to divide by x, because that'll cancel it out over here. Divide by x here. So I get y equals 5 over x.
Which
Is y now by itself?
yeah,
Yeah,
that's inverse.
it is inverse, isn't it? Because it takes the form y equals a over x. Does everyone see that? So I would say inverse variation. Does that make sense? We solved it for y. Took the form y equals a over x, so I know it's inverse variation. Questions on A? Okay, letter B. Is B already solved for y? Y equals x minus 4. Yeah, y is by itself, isn't it? Does that take the form y equals a over x? No. So is it inverse variation?
No.
No. Does it take the form y equals ax? No. So is it direct variation?
Nope.
No. So which one is it?
Neither.
Neither. This isn't too bad, is it?
No.
We okay? Any questions on A or B before I move to C? Okay, letter C is y by itself.
No.
No, it's being divided by 2. So if it's being divided by 2, what inverse operations would I do to both sides? Multiply by 2. So I get y equals, what's x times 2? 2x. Does that take the form y equals a over x?
Yes.
It does?
No.
No. So is it inverse variation? No. Does it take the form y equals ax? Yeah. Some number times x. So what kind of variation is this? Direct variation. Any questions on classifying equations as inverse, direct, or neither? Solve it for y. If it takes the form y equals a over x, it's inverse. If it takes the form y equals ax, it's direct. If it doesn't take either of those forms, it's neither. Everyone got that? Any questions on it? Let's say I gave you this equation. Y equals x over 3. What variation would that be?
Be, inverse.
I've heard all three options.
Wait,
So which one is
be
it?
neither because x is over 3 and x is supposed to be on the bottom.
So what do we say it is? Neither? Are you sure?
Yeah.
Yeah.
This is direct.
Oh, so I was right. You made me double guess, second guess myself.
This is going to be written as 1/3 times x.
Oh,
So that's some number times x. Okay? So be careful with that. That's why I wanted to show you.
Can you explain
That is
That could
direct
make no
variation.
sense.
hold on.
So if I have x over 3, that's the same thing as doing 1/3 times x. Because if we use our rule for multiplying fractions, x as a fraction is x over 1. Multiplying straight across, what's 1 times x? 1x or just x. What's 3 times 1? 3. Does that help make sense? So just be aware of that. If you've got x over a number, it's like that fraction being multiplied by x. So that'd be direct variation. Okay? Questions on example 1? Okay, example 2. Classifying data. It says tell whether x and y show direct variation, inverse variation, or neither. Okay, I hope this part is not too confusing. Earlier we had, for direct variation, y equals ax, correct? Well, do I have any a's in any of my charts? What do I have in my charts? Just x and y. So let's solve this equation for a. How do I get a by itself here?
By dividing and then subtracting.
Dividing by
A.
x. Trying to get a by itself. So a equals y over x. Okay? So on your paper where you put direct variation, y equals ax, I want you to also put a equals y over x. Okay?
Is that also inverse variation?
Hmm?
Is that also inverse variation?
That's direct. Write this for direct variation. Up at the top of your paper where you wrote direct variation and y equals ax next to it, put a equals y over x. Okay? Can I erase that? For inverse variation, we had y equals a over x, right? Everyone okay with that? How would I get a by itself here? Multiply by x. A equals xy. So put that next to inverse variation, where you wrote that at the top of your paper. So we have our two, what's the word I'm looking for? We got a product between x and y, and we got a quotient between x and y. So that's what I'm going to do with all my x and y values. for my first chart. I'm going to multiply my x and y values and divide my x and y values. This is all for letter A. So I'm going to make myself a little chart for x times y and for y divided by x. So I'm going to do that for each of these things. So x times y, what's 2 times negative 12?
You're subtracting by 10.
What's 2 times negative 12?
Negative 24.
Negative 24. Everyone see that? I'm just multiplying x times y. Because this is one of the relationships between one of my variations, right? For A. Now what's y divided by x? Negative 12 divided by 2.
Negative 6.
Negative 6. Everyone okay with that? We're going to do that all the way down for all of these. What's 4 times negative 6?
24.
Negative 24. Negative 6 divided by 4. Be negative 3 halves. 6 times negative 4.
Negative 24.
Negative 24. Negative 4 divided by 6. What would that reduce to? Negative 4 over 6.
I'll say 0.07.
As a fraction. Negative what over what? 2 over 3. And the last one, 8 times negative 3. Negative 24. And I'd get negative 3 over 8. So which has the constant thing going on? The product between x and y or the quotient between x and y? Product. It's negative 24 each and every single time, isn't it?
Yeah.
So up at the top of your paper, was it direct or inverse variation that had a equals x times y?
Right.
Do what?
Wait, what? Oh, that's.
Inverse, right? So, since the product is constant, would you say this is inverse or direct? Inverse variation. Does everyone see that? We saw the relationship between x and y whenever we solve for A. For inverse, it's x times y. For direct, it's y divided by x. So I just do that with all the values in my table. Multiply all the x and y values together. Divide y divided by x. Whichever one's constant, that's what variation you're going to have. So if neither one of them are constant, you would put neither. Does that make sense? Okay. Questions on letter A?
What if they were both constant?
I don't think you'll ever get them both being constant. Can I erase and move to B?
Well, what happens if it's like 1-to-1?
Say it again.
What happens if it's like 1-to-1? Like the x is all wins, the y is all wins.
Then that's just going to be 1 point on your graph, and you're not ever going to see that either. Letter B. We're going to do the same thing. Multiply our x and y values, and then divide them. So what's 1 times 2 for the first set?
Oh, that's 2.
2. And then y divided by x, 2 divided by 1 gives me
2.
2. Second ordered pair. 2 and 4. What's 2 times 4? 8. Y divided by x. What's 4 divided by 2? 2. 3 times 8. 24. 8 divided by 3. 8 over 3. And then 4 times 16. 64. 16 divided by 4. 4. So is either the product or the quotient, are either one of them constant? No, they're both changing it up. So what would I put? What kind of variation? Neither. Everyone okay with that? Any questions on it? So yeah, if you get the product as being constant, it's inverse variation. If you get the quotient being constant, it's direct variation. Neither one of them's constant, it's neither. You okay with that? Any questions so far? Can I move on? Okay, writing an inverse variation equation. The variables x and y vary inversely, and y equals 4 when x equals 3. Write an equation that relates x and y, then find y when x equals negative 2. So don't overthink this. How does it say x and y vary? What kind of variation do we have here? Inverse, because it says they vary inversely. So what was that formula for inverse variation? Solve for y.
I got you. Y equals A over X.
A over x. So this is the formula I'm using. From here, it's just plugging in values. Okay? So it says y equals 4 when x equals 3. So what do you think I'm going to do with these values?
Plug them in.
Plug them in where?
And then spot.
Right. So what are we plugging in for y?
4.
4. What are we plugging in for a?
Nothing.
Nothing. So it just stays as a. What do we plug in for x?
3.
3. There's my equation, right? But it wants me to find my a value so I can come up with an equation that's in this form. Okay? So how do you think I'm going to solve for a here? What? Get a by itself. How do I do that?
Times 3.
Multiply by 3 on both sides. So what does a equal? 12. So my equation that relates x and y when y is 4 and x is 3 is y equals 12 over x. So that's the first thing it wants from me. We plugged in the values it gave us to get our a value, and that helps us get our equation. The equation that relates x and y is y equals 12 over x. Any questions on that? Now, what does it want me to do? Yeah, plug in negative 2 for x, and it wants me to find y when x is negative 2. So I replace x with negative 2. What's 12 divided by negative 2? Negative 6. So what does y equal when x is negative 2? Negative 6. That's all it wants from me. There's my answer. Any questions on example 3? Do we think we can do a problem like that on our own?
Yeah.
See which variation it's telling you they have. Use that formula. And it's going to give you an x and a y value. Plug those in so you can get your a value. That a value will help you give you your equation. Plug that a value in for a. So you'll get y equals some number over x or some number times x if it's direct variation. Then you have that equation. You can plug in another number that it asks you to plug in to get your remaining value. Questions on example 3? Good? Okay, let's move on. Example 4. Word problem. The time t in hours that it takes a group of volunteers to build a playground varies inversely with the number n of volunteers. It takes a group of 10 volunteers 8 hours to build the playground. First thing it wants me to do is make a table showing the time that it would take to build the playground when the number of volunteers is 15, 20, 25, and 30. Does everyone understand that? So it varies inversely, right? So the formula we're using is y equals a over x, right? In this case, though, do we have x and y?
No.
What variables do we
How
have?
do you just tell that as
Because it says it varies inversely.
Where?
Yeah. Time t in hours that it takes a group of volunteers to build a playground varies inversely with the number of volunteers. So which two variables do we have? we don't have x and y. It gives us other variables, t and n. So instead of writing x and y, I'm going to write t and n. So that's the formula I'm going to be using. T equals a over n. Okay? So let's make a table. I'm going to make a table on this next slide. We have t and n. I'm going to write n and t. What are the n values it gives us? 15, 20, 25, and 30. And it wants me to make a table showing the time that it would take to build the playground when the number of volunteers is those things right there, 15, 20, 25, and 30. So we're going to kind of use our formula down here because it gives me two values that it shows me how long it's going to take a certain amount of volunteers to do something. What are those values? On that second sentence.
It takes 10 volunteers, 8 hours.
Yeah. So what am I plugging in for T?
8,
8. What am I plugging in for N?
10,
10. And now I'm solving for A.
right?
Yep. How would I get A by itself?
Times it by 10.
Multiply by 10 on both sides. So what does A equal?
8.
80. So my formula is T equals 80 over N. Does that make sense? That's very similar to the previous example we just did, that first part. This equation is now going to help me fill in that table that I created on the next slide. I'm going to take each number that it gave me and put it under 80 and do 80 divided by those four numbers. Does that make sense? So, here I've got to do 80 divided by 15. Because remember we're doing T equals 80 over N. These are the N values it gives me. So 80 divided by 15 gives me, what does it give me? 5.3333. As a fraction, that would be 16 over 3. But we're dealing with time, right? So I need to calculate this where it's time. So what would 16 over 3 be as a compound number? How many times does 3 go into 16?
5.
5 times. What's 3 times 5?
0.3.
3 times 5. So 16 minus 15 would give me 1. My denominator is 3. I just converted this to a compound number. Okay? But I still need to get it into hours and minutes. So I've got 5 hours. And what would 1/3 of an hour be? How many minutes? 20 minutes. So it would take 15 volunteers. 5 hours. And 20 minutes. Does everyone see that? It wants it in time, so I need to use the units for time. Everyone okay with that? Second one, I'm doing 80 over 20. What's 80 divided by 20?
4.
4. That one's easy. It's just 4 hours. Everyone okay with that one? Now I'm doing 80 divided by 25. That gives me 16 over 5. Just type that in my calculator. So what would 16 over 5 be as a compound number?
3 and
3 and what? 1/5. So that's 3 hours. And 1/5 of an hour would be what? How many minutes? Not 10. 12 or 5 times what would give me 60? 12. So how many minutes is it? 12 minutes. And lastly, I've got to do 80 divided by 30. Which gives me 8/3. What is that as a compound number? 2 and 2/3. So that would be 2 hours. And 2/3 of an hour would be how many minutes? 40 minutes. Everyone okay with that? So there's my table that it asked me to fill out on the first part. Yeah, I'm going to go back. That's the first bullet point. Make a table showing the time that it would take to build the playground when the number of volunteers is 15, 20, 25, and 30. Now it says what happens to the time it takes to build the playground as the number of volunteers increases.
Decreases.
Very good, yeah. The more volunteers I have, the less amount of time it takes to build the playground, right? So I'd say the time decreases.
Good job, just common knowledge.
Yeah, it is.
Sometimes, if you have like way too
I
many.
mean, sometimes people get in the way though.
That's true. But in this case, it looked like the people were helping.
Yeah.
Time decreased.
I give that.
And that's the end of example 4. Are there any questions on it? We good? Can I move on? Example 5. Just kidding. Pages 369 through 370, 4 through 26 evens. Get it written down. 369 through 370, 4 through 26 evens. Are there any questions about the recording before I end the recording?